this series of videos I'm attempting to repair and restore this HP9845B vintage computer. So far in this series I've stripped the unit down into its major sub-assemblies, I've gone through the power supply, rebuilt that, replaced a few parts, and the power supply now seems to be behaving itself. It does appear, if you've come from the previous video, that I've made a big step forward here, but you really haven't missed very much. All I've really been doing is going through each of the cards with a multimeter and checking that there aren't any obvious shorts on the output. I haven't gone through the whole thing, but I have checked all the caps and the power rails, but mostly I'm looking to make sure there's nothing obvious on the edge connectors that is likely to cause damage if we plug these in. And it doesn't guarantee it's going to work, it's just, as I say, to make sure we don't damage anything, because with these machines it's not really feasible to test the boards one at a time. You can go through them and do the static testing as I've been doing, but really you need a minimum set of boards plugged in for the machine to really do very much. Having said that, you don't need to plug them all in, so I'm going to start by leaving out this board. This is the printer control board, so we can leave that out. I have gone through and tested it with a multimeter, and as I've tested each board, I've fitted them into the chassis, powered it up, checked the supplies to make sure nothing bad was happening, checked the current draw, and I've gone through and I've plugged back in the LPU card itself, the processor card, and the LPU ROM and RAM card. So really each of the two processors consists of two basic cards. You've got the processor card itself, so that's the one that has a big heatsink on it, and then each one has a ROM and RAM card. It's a combined ROM-RAM card, so it's got both the ROM, the basic system ROM, and the basic system RAM built into it. And the same is true for the PPU. It consists of two cards, the processor card itself and its ROM and RAM card. I can also leave out the backplane. We don't need that for the basic system to start up. This particular machine has two expansion RAM cards, and again I can leave those out for now. I know one of these has at least one fault. It shows a short across one of the pins, so I don't want to fit that anyway. The other one doesn't show any obvious faults, but I'm going to leave it out for now anyway. We don't need these plugged in for the basic system to start to come to life. As I've already said, there are two processors in this machine. We've got the language processor and the peripheral processor, and they kind of work together, but they perform very specific parts of the processing operation. They're not like a modern dual core processor. They're not both doing the same thing. They're responsible for processing different parts of the system operation, but they do interact, and to a certain extent you can view them as separate entities. So each processor has its own system ROM, so it's a processor and it's got its own system ROM card, and each one has a system option drawer. So you can take the drawers out, or you can just remove all the modules from them to minimize the amount of devices that are connected to the buses and reduce the possibility of any of them hanging the system. The same is true for the PPU. It's got the processor card, the ROM RAM card, and again it's got its own ROM drawer. And again, you can take the ROM drawer out and the system will still start to try and boot up. Now the system won't actually boot up even if it's working without the monitor fitted. We'll come back to that in a minute and how to work around that. But it will start to try and boot up even without the monitor fitted, even if you don't do anything else. It won't boot up, but it will start to go through the process and you'll be able to see activity on the processor cards even though it won't boot up. I've got the keyboard and the drive, the tape drive controller boards plugged in. I don't believe the system's going to start up because of some of the things I've seen on the cards, but we'll give it a try. I've also got the two interconnect cards plugged in, so that's these two that connect up to the CRT, the monitor. Again, they both need to be in or the system won't do very much. The main system clock is on the LPU card, that's the one on the right here. And so we'll start at this side, we'll power this up. I have powered this up already and checked the power supplies. Obviously have the test points on the top, and all the supplies look good, even with these cards plugged in. So it won't boot up properly, I'll explain why in a couple of minutes, but what I want to do first is see if there's any activity on this card at all. So we'll power this up. And I'll start probing around on the processor card and we'll see if there's anything actually running. Okay, so as you can see, almost nothing happening there. There's no activity. It's not getting hot, but it's just not doing very much. Why don't you just check to see if the clock's running. So the clock's actually running, but the system's doing nothing at all. Now, I've worked on these before, and there is a particular issue that I've seen on a number of occasions. Let's pop the processor board out from this side. So the main part of the processor system is under here. There's a hybrid module. This is part of the hybrid module. Now, it's actually quite a thin substrate module, and it's sandwiched between the PCB and the heatsink and the module itself. So if you take these nuts off, you can lift the heatsink off, and normally the module, the hybrid module, will come away with it. And then there's what amount to zebra strips around the outside that connect to these points, but on the other side of the board. It's not actually a zebra strip in the normal type that you see in LCDs. The kind of plastic tubes with gold bands around them, but it acts like a zebra strip. It's just to transfer the connection from the underside of the hybrid module to the board. And because these are kind of open on this side, and if you could see underneath this gap, you'd be able to see where the connections are between the module and the board, and they get dirt and moisture, and it starts to get a bit of corrosion on the pins. So what I've seen previously is the modules don't make proper connection with the board. So you take these nuts off very carefully. This heatsink will only go one way around, by the way. So take this off. The module normally comes away with the heatsink. There's heatsink compound between the module and the heatsink. I normally change that, take it off and clean it and put fresh heatsink compound on there. It's important that the hybrid modules don't get too hot. They do dissipate quite a bit of heat. And then I use IPA to clean the contacts and also the zebra strips. So I'm going to do that on both processors. We'll plug them back in and see if that gets us any further. Okay, well, I dismantled and cleaned both of the hybrid modules. They were fairly dirty. Some of the contacts did appear to be fairly corroded and have a lot of dirt on them. So here's a close-up view of the before and the after, and hopefully you can see that there was quite a bit of dirt on those contacts. So I've cleaned those off. Haven't done anything else yet, but I'll put this back into the machine. So I've done the other one as well. So I've done the PPU and the LPU, both the same. I've cleaned both of them, reattached them. I did replace the heatsink compound. The PPU hybrid module actually wasn't attached properly to the heatsink, so I'm a bit concerned about that. It might have fried it, but it is now properly attached with fresh heatsink compound, but just have to hope that works. So we'll now power this up and see if we've got any life in the system yet. It's running about the same current, so nothing bad is happening. So we'll try monitoring this and see if we're getting any activity yet. Okay, well that's quite a big step forward. We are now seeing some activity. I'm just going to reboot it, make sure it's just not fluke. They can act a bit odd, and sometimes they'll start up, sometimes they won't. But we'll try rebooting it and see if we're still running. So at least it's now doing something. Signals don't look particularly good. So you can see the signals are all over the place, so there's something not quite right. It could be we've got a failing buffer or something like that, or it could be the hybrid module itself. What I want to do now is just see if there's any activity at all. There's a fault light on this 55 card, and we should be able to make that come on if it's not running by pressing the stop key. So I'm going to press the stop key on the keyboard. Probably can't hear it. I'm just going to move the camera so you can see the LED. So hopefully you can see the LED. I'll press the stop key again. So I hope you can see that LED coming on. I'm going to press the control key, and if it's latching that signal, then pressing the control key should also make that LED come on, which it is doing. If we reboot it, and now press the control key first, the LED should not come on, which it isn't. But if I now press the stop key, that enables that signal. So it basically means this is not starting up. It's trying to access the ROM by the look of it. We'll just make sure it's still doing the same thing, and it is. But looking at the condition of some of the signals, either we've got some faulty devices on the board, or it may be the ROMs themselves that are failing. The ROMs are fairly unreliable on these machines, so it could be the ROMs are failing. Luckily, each of the processors has this test connector along the top, and the PPU has an identical one, and so we can connect a logic analyzer to that, which I suspect we're going to end up doing. But the next thing I want to do is, I said that the machine won't boot up without the monitor fitted, and the reason for that is the startup on this machine is a bit unusual. There are two processors, but when you first turn the power on, they don't really know which one they are. So the way the two processors determine which one's which is they look at the halt line. The halt line going into the LPU, the one on the right, is permanently wired to ground. The halt line on the processor on the left is driven from the vertical drive output of the CRT, the monitor. And that signal is about 1 millisecond low pulse every 16.6 milliseconds. So it's a repetitive low pulse. So when you boot up the system or reset it, both processors will branch to the same part of code in ROM, and they will both start executing the same block of code. And that starts off with what I think is an internal processor reset instruction, and they will then jump to the initialization address, but it's the same block of code for both of them. And what they have to do is determine which one's which. They have to determine which one's the PPU, which one's the LPU. And the first part of the code is to carry out that test, and what they do is they look at the halt line. Because the halt line on the LPU is permanently wired to ground, it will always be low. Because the halt line on the PPU is driven from the vertical drive signal for the monitor, it can be high or it could be low depending on which part of that cycle it's in, and because they're not synchronized, the PPU has no way of knowing exactly when it's looking at the signal. So if it looks at the signal and the signal happens to be low because it happens to be sampling during the low part of that signal, it will come back a few milliseconds later and retest the signal, and if it's then high, it knows it's the PPU and it will branch to the PPU block of ROM code. If on the other hand it's the LPU that has a halt line that's permanently grounded, it will do the same thing in as much as it will look at the line. It will of course be low, but it doesn't know it's not the PPU, so again it will come back a few milliseconds later and check that line again. It will of course still be low, but now it knows that it's the LPU. So if it sees low all the time, it knows it's the LPU, it will branch to the LPU block of ROM code. If it detects a high signal on that line, even after initially seeing a low signal, it will know it's the PPU and it will branch to the PPU block of ROM code, and then they will start running their own ROM code, the PPU executing its own ROM code and the LPU executing its own ROM code. But if you reboot the system, they will both branch back and start the process all over again. So it is quite clever, and what it really means is that even if you don't have the monitor plugged in, they will go through that first part of the initialization, and what it should result in, if you don't have the CRT or the monitor plugged in, is a continuous series of beeps, because the system will beep when it first starts the boot up process, but then because it's failing, it will go back and try again. It will keep doing that, and you should get a continuous series of beeps. This didn't beep, so that's why I didn't think it was running. It could be a faulty speaker, of course, but I haven't looked into that yet. But what I want to do now is try and fool the system into thinking that the monitor is fitted, so that we can actually see if the system will get any further and if it changes the signal we're seeing on the scope. So I'll just get that prepared. So all we need to do to fool the machine into thinking the monitor's fitted, and the reason I don't want to fit the monitor, by the way, is we can't then access the boards very easily, so I want to keep it out of the way. I know the system isn't running, so it's not really going to help us that much having it fitted, other than to get the system to go through its normal startup if it will work. But what we can do is fool the system into thinking the monitor's fitted, and all we have to do is feed a suitable signal into the halt line on the left hand CRT connector, and we also need to ground the CRT or the not CRT line. That line is just pulled low whenever the monitor is plugged in, so it lets the system know the monitor is present. So we can do that very easily. HP had a what they called a startup fixture. It's just a small board plugged in. I don't have one, never actually seen one, but we can quite easily cobble together something ourselves. This is just a 555 timer. It's configured in a typical astable multi-vibrator mode, so it will give out a suitable signal, and all we have to do is plug this into the correct connectors on our edge connector here. To make it easy to connect, I've plugged in an adapter for a floppy disk interface. This is just a edge connector to IDC type connection, and that allows us to plug the jumpers directly into it. So all we have to do is connect the output of this test. This is effectively our startup fixture. All we have to do is connect the output to A1. We then need to connect the CRT, the not CRT line, to ground, so that is A3. We then need ground and power, so the ground pin is this one, and then finally we need some power, so we need 5 volts. So we can just connect that to the 5 volt output, which is that one. So that should now work fine. I'm just going to test this, so I'll put the scope on what should be our vertical output signal, and we should see a series of negative going pulses if I power this up. And that looks correct. The scope's saying it's 16.7 milliseconds, that's close enough. And we've also grounded the CRT line. So what I'm going to do now is start probing around again, see if it seems to have got any further. I don't think it has. It hasn't beeped again, so I don't think it's actually starting up. But we'll do a bit of probing, see if there's anything going on or if it's changed at all. They're still not looking good. Okay, so it looks like the processor is trying to start up, but it's failing to. Most likely that's a faulty ROM. It could be the hybrid module, or it could be one of the glue chips. So what I'm going to do now, I'll do it off camera because it will be quite tedious, and also it's quite difficult reaching around the camera. It's quite a long machine, so I'm sitting almost a metre away from it, and that's a good way of blowing something up. So the next step in trying to get this sorted out is I'm going to start probing around, looking to see what's going on. I do have the schematics for this, that makes life a lot easier. And I want to try and find out how far it's getting through the startup. So I'll do some basic probing around. I somehow doubt that will yield anything, so really the next step we'll be looking at in the next video is probably going to be to connect a logic analyzer to this, and then we can start looking at the boot up process. I also have copies of the ROM code, so I can see if the processor is correctly fetching the correct ROM code, or if there's a fault with the ROM board itself, and then we can start tracing through the operation of both the LPU and the PPU and see which is not working, or if either one is working. But either way, it's not getting very far through the startup. I kind of expected this. These machines do tend to be a bit unreliable, but in particular the ROM boards and the RAM boards on these tend not to work that well. In fact, I found the monitor has the graphics option card in it, and that had some faults, some manufacturing faults that never would have worked. So kind of strange, but we'll look at that in a future video. I don't have any replacement parts for this or spare parts, so we are going to have to go through and do this the hard way. It would be nice to have some sort of boards to swap out to see if it works, but without those we have to go through this the long-winded way, and hopefully we can track down what's not working. But as I said, if I can't make any progress by trying to scope out the various circuits, which I suspect will be the case, then we'll move on to the logic analyzer, which we might well do that anyway, even if I can find what's causing it to not boot up, because it will be quite interesting to look at how this system works.